Okay everyone, this is going to be the printer overview for the Termin8tor SLA DLP printer. It's technically a DLP because there's no laser, but it's still similar or in the same class as an SLA printer in the way it operates. So anyway, the reason I chose to build this printer is cost at the time. I started it about a year and a half ago. Built it in my free time. A lot of the printers similar to this as far as the build volume were $2,000–$3,000 and up. You can get small printers, but I wanted something with a larger build volume, so I built it for cost. Also, obviously, like I just said, I wanted a larger build volume than you could find on average. The total cost of the printer is around $900 US. I also wanted something that was a complete solution that would filter the air. So this unit has, you can kind of see here in the bottom, this is the filter, and that it might show up there, the bottom of the filter box and the top there. They are actually carbon filters, so they absorb all the fumes when the air goes out. So you don't really smell anything. You can run this in a small room, you don't smell anything. So wanted that as well. I wanted a modular design so that anyone could change the overall setup of the printer. If you want to put a laser down here similar to the Moai SLA printer, you could put a laser galvo setup in the bottom instead of a backlight. So it's very modular. You can easily change out any of the parts because the frame is built on the open build V-rail. So all of them bolt to the rails very easily. Just design your own 3D printed parts and change up what you want to. You could also put an ultraviolet backlight. This is a daylight DLP printer, so it uses daylight 460 nanometer resin. So mostly photocentric for now, makes that type of resin. And you could also change out the screen size in here if you want to. This is an iPad Retina screen, so if you wanted to put something slightly larger or maybe smaller, you could easily change the screen out without changing any other parts, because the way the bed is set up in here, I'll show you later, it's very easy to swap the screen out without changing anything. In fact, you could actually leave the vat and the print platform oversized and put a smaller screen on there and the printer would work the same. So the machine size, the total size of the machine, is going to be 340 millimeters on the width. It is 380 millimeters from the front here to the back corner. And the height from here all the way to the top is going to be 815 millimeters. So basically 34 centimeters by 38 centimeters by 81.5 centimeters tall. It uses 20 by 20 V-slot rails from open builds for the entire frame except for the Z-axis. Those are 20 by 40 because they're much more rigid. I built the machine and ran it with 20 by 20s that I had a brace on, but eventually I realized they needed to be stiffer, so at the last minute when I got the machine completed, I disassembled it, almost completely as far as the internal part here, so I could get to the Z-axis, and I just changed it out to 20 by 40s, redesigned some of the little brackets to hold the in-stop switches, and now it works beautifully. There's no movement, so it's working wonderful now with the 20 by 40s. The case is acrylic. It's 3/16 thick. It's numbered 2423, which is a transparent, translucent red color, basically. So it's not fully transparent, obviously, but it's transparent enough to see through. The hinges are all taped, so I'll show you in a minute. It opens up, but all of these hinges are just clear tape, so cheap and quick, and you don't really see them. And the case has magnetic latches, so I've designed custom magnetic latches to keep all the doors and the wings closed, so it'll easily open and close and keep itself airtight when it's running. You won't smell anything. So I can go ahead and show you the side wings here, how they move in a minute. And I have, just one last note, I have the fans set up to a slightly negative pressure. So basically over here on the left side there's an input fan that pulls cold air in with just a dust filter on it. And then I have an output down here with a filter box and an output in the top with a filter box. And the outputs are set to output right at the same flow or slightly greater than the input, because I have a little trim pot, or basically a speed adjuster, on the input fan. So I slowed down the input fan until the outputs were equal or slightly faster, and that ensures that you don't get any air leaking out of the seams and you don't smell the resin. But it still stays fairly cool. And one last thing about this printer that is fairly good for its build size is the resolution. It has a X and Y resolution of 100 microns, which is basically the width of a human hair. So 0.1 of a millimeter on the X and Y axis, and the Z axis would be even finer. You would usually run it at 0.1, 0.05, 0.03. So it has very good resolution considering the size of the screen. A lot of printers with that size screen, sometimes they have lower resolution down to like 180, 200 microns because they're not that high of resolution monitor, but it has a very good resolution as far as X and Y, so it can print very small stuff. Okay, so the only thing on here that's not completely original that I didn't design would be the printer head here that holds the arm, or the print arm here. This little head setup originally was the Crystalia head, so thanks to the designer of that. I did heavily modify it because I found that I didn't need it. I had to change it, so I redesigned a lot of it. This bottom portion here that actually holds the build platform is completely original as far as my design. I just adapted it to fit the original design that the person set up, but I changed out that, the entire lower portion. And then I also heavily modified the arm itself that comes off the Z-axis so that it would be more rigid because it was a little too flexible, and I also changed it so that it would bolt onto a open build plate in the back, and it's also shorter, so I shortened it up to basically reduce the leverage, because when it's peeling parts off the build platform, you have multiple parts down here. There's a lot of tension pulling down. So if the arm is too long, it gets a lot of leverage going on, and it starts twisting the Z-axis. So the less leverage, the better. In other words, the closer the platform is to the Z-axis, the less leverage you have working against the Z-axis. So redesigned that as well. So one thing I did experiment with a lot before I got a successful part adhesion, because that's a big issue with SLA, is parts falling off the platform. A lot of times the part doesn't stick correctly to the platform, or it sticks and then halfway through the print it falls off. But I had success with, this is a Ziploc here because there's a bunch of resin on this stuff, or at least residual resin, but this is what I'm using now, so I don't know how well this will show up on the camera, but it's basically perforated steel. I forget the gauge, but all the details are in the bill of materials list. But basically you have to mark this out and enlarge. After you drill the holes, you have to enlarge them with a Dremel, otherwise they'll drift, because it's very hard to maintain a drill bit in a mesh like this. It wants to move all over the place and then it doesn't line up. But anyway, this is what I'm using, and it's perforated steel. This has the best grip. My prints never fall off. It works great, and it's easy to get the resin off of it and rinse it out. So I also tried, this is actually the back side of the board. The other side looks a little different, but this is basically a PCB board for doing electronics. So it's perforated with holes, and if you look on the other side, there's little, silver rings where you would solder on connections. But I tried this before I went with the perforated steel, and the parts didn't stick that well either, and they fell off. I also tried solid aluminum, just a solid aluminum print bed, basically like this, but no holes in it at all except for the bolts that hold it. Parts would peel off of that because when they start shrinking during the print, the shrinking forces would eventually deform the object and make it peel off, and it would fall off during the print. So that didn't work. And I also tried the same thing, but I bought a piece of anodized aluminum because people said, well, anodized sticks better. So I got a piece of anodized, was very careful not to scratch the anodized surface, even though it's pretty hard. Drilled that out. I even perforated it with holes every, I want to say maybe 15 millimeters. I manually drilled about 50 holes in it to give something for the parts to grip onto, so it wouldn't be super slick. And I did try it before perforating it. The parts did not stick that well. They fell off. So after I perforated, I tried it again, and the parts still fell off. So the only print platform I had success with was the perforated steel, which is what I'm using here. I believe it's 16 gauge. So that's the platform that works great for me. Don't have any issues. Works amazing. So the print size on the Terminator would be 196 millimeters by 148. So if you want to rough that out, it's basically 200 by 150 on the X and Y axis here for the screen. So 200 by 150 build volume, and then the resolution, as I mentioned earlier, is 96 microns, which is basically a human hair width. The print height is roughly 260 millimeters maximum. So if you were to run this platform from the very bottom here on the screen all the way up until it hits the end stop up here, which you can't see probably, it's 260 millimeters. So you have a 200 by 150 by 260 on the z-axis. So it's a very large build volume. You can print a lot of parts, tall parts, if you want to let it run for 15, 20 hours and just let it run in a spare room or whatever. You could print very tall items such as like the Eiffel Tower or whatever parts you're building. So there is some wasted z-axis space here because the distance between the actual build platform here and the bottom of the arm is a good, I don't know, maybe 15 centimeters. So you do lose about 150 millimeters in there just because of the design of the parts, but most of that space is necessary so the parts are stiff and they won't deform when it's pulling the layers off the film. You could move this further up here by compressing the springs and get a little more build height, but it's not really necessary. I found that 260 millimeters is higher than anything I'm ever going to print on this machine. So, okay, so the cure times for this machine, the average cure times for a layer are anywhere between 8 and 10 seconds for most of their resins, such as photocentric hard resin, the firm resins. Not all the resins are the same, obviously, but they average about 8 to 10 seconds per layer is a sufficient cure for the part to survive, even if it's a fine detail part. But to give you an idea of the print speed, if you were to print something from the bottom of the vat all the way to the top, so 260 millimeters long or tall, that would be a 30-hour print. So it would be a 9-second cure plus a 12-second travel. So the 12-second travel would be the time it takes to pick the part up, peel it off the film, and go back down for the next layer. So, and those would be 50 micron layers. So that would take 30 hours for 260 millimeters this way with 50 micron layers, 9 seconds plus 12 per layer. Okay, so if you were printing at 8 seconds with an 11-second travel, which is what I currently am using for the hard photocentric resin, you can get 9.45 millimeters in 1 hour of Z height. So that's almost 1 centimeter per hour. Very, very close to 1 centimeter per hour. And I did successfully print a calibration cube from Creation Workshop at 6 seconds, and the little films that cover the boxes did survive at 6 seconds. So theoretically, you could print all the way down to 6 seconds if your part wasn't too fragile, and you could probably go a little bit over that speed. But it's right around 1 centimeter per hour with 8-second layers. If you were to print at 14 seconds with an 11-second travel and use 100 micron height for the layers instead of 50, you would achieve roughly a 14.4 millimeter per hour distance on the Z. So basically 1.4 centimeters per hour if you were printing with 14-second layers that were 0.1 of a millimeter thick instead of 0.5. So pretty decent speed, I think, especially for the size of the machine. Okay, so I'm going to show you guys now how the case opens up. You basically just grab this little lip here, it sticks off, and it just pops open. There's a hinge here, there's a magnetic latch on the bottom and the top corner. So this part swings open. I'm going to take it all the way around to the side here, out of the way. So that's how easy it is to get in the machine. You just open it. When you close it, boom, it closes. That's it. It's done. This right wing, I put 2 wings on it as well. I didn't want parts that swivel up or stuff like that because a lot of machines have a design and they just end up in the way. Or you have to have a lot of room behind the machine or beside it or something like that to open them. So this machine you can get in pretty easily without a lot of space around it. So this wing on the right just unclips. There's a latch here at the bottom that holds the front door. So when the front door comes closed, it uses this latch. And there's one at the top. There's one at the top there that allows it to snap shut. So this wing, if you want to service it or get your hands in here more, you just flip this open to the side like this. Okay, so here's the machine with all the doors, or the wings I call them, opened up. So there's no disassembly required for this. You literally just pop the front door open, swing it over. This one is attached with the latch here. So you just pull a little bit, this latch pops out. Same with the top. Whole thing, you can just swing it out of the way wherever you want. The right one just swings out of the way. So it's very easy to get into this machine. If you need to disconnect something here, if you got to service something, you need to get to one of the limit switches, doesn't matter. You want to get to the filter box, you want to take this apart, you want to get down in here, you just swing them open and start disassembling. It's that simple. So it's a very open design, and the case fits really well. The total number of fans in this machine is 13, so it does have a moderate noise level, mostly caused by the RPM of the side fans. The fans that are pulling air through these filters are low profile 15mm fans, and the reason for that is not necessarily because of the space, but because they generate more suction. They spin faster and they generate a better suction than the standard fans, and the standard fans will not pull air through these filters. They barely pull air through, and then you end up with the case overheating because your output is so low. So I had to use low profile fans to get enough airflow through these filters, and they sound louder, so it's just part of the way it was set up. You could use a 38mm fan. This one wouldn't have room, but in the top you could use a 38mm fan, which is basically almost like a turbine. It has a lot more suction than even the low profiles, but once again they have a really high decibel, so you're going to get a lot more noise even though you have more airflow. You could dump the filters completely and use the quiet fans and the whole thing would be quieter, but then you have no filtering, so that kind of defeats the purpose of the filters in the first place, was to make sure you don't smell the machine. Because a lot of machines like the Form 1 and all the other SLA machines out there, not all of them, but most of them, they have no filtering. So you got to buy a $1,000 printer, $800 printer, and then you go spend another $500 on a filtering system to connect to it so you don't smell it and it doesn't choke you out. So I wanted it to be self-contained. So anyway, the wattage used for the lights, the backlights down here, is roughly 80 watts, which is 2.5 amps at 32 volts, and that comes out to 80 watts. And there's basically just 4 chips down here. So there's 1, 2, and then behind this bank here, there's another bank. So it's 4 20-watt chips running at full power for the cure times I mentioned. And there's obviously fans down in here to keep everything cool, keep these heat sinks cool, and little electronic fans and whatnot. So anyway, the heat generated at 80 watts is moderate. So it's not really, really bad, but it's fairly warm. So if you run this in a hot room, you're going to have problems. You're going to probably have to open the case every so often to let it cool down and then close it again. If you run this, 5, 6, 8 hours at a time for a longer print, you'd want to make sure that room is probably 75 degrees or lower, or you're going to have overheating problems. But other than that, it works very well. The only thing I would recommend when you're building this is order everything first and then start the assembly, because it's going to be much easier if you have all your parts and you can just start assembling it. So I don't know if you can see it on camera, but the back panel here, you might be able to see here in the back corner, or possibly over here in the top somewhere. I closed that up with Fuse-It, which is made by Liquid Nails. So Fuse-It is basically a high strength glue. It looks like silicone, it's gray, but it's actually a glue. And that's the only thing I found that would really stick to the acrylic, because the back itself is basically permanently fixed to these back quarter panels. So these panels go from the top all the way to the bottom of the machine. There's no break like these wings have, and those are what give the back the rigidity. So, okay guys, so this is the vat design. I'm going to show you now how it works. It's very simple. I designed the vat. There's these little thumb screws or nuts that just come off these, clamp the vat and hold it down against the screen. But basically there's just 2 bolts here on the side, so it just slides up, take it out. It's only 2 pieces. So you've got the front of the vat here, or the top of the vat I should say, and I painted before I assembled it, I painted the inside with silicone so that the resin wouldn't want to sit and lodge into the plastic. And then you have the bottom of the vat, and that's it. It's only 2 pieces. This is what I call the seal. It's not really a seal, it's plastic, but it just goes in here and clamps the FEP film and gives it a lot of tension. There are a lot of bolts in here, but that was necessary to make sure there was no loose areas. So it's pretty simple. There's literally only 2 parts to it. You must have a printer that is 300mm at least on one dimension of the build platform in order to print the vat. If you don't have a 300mm printer, have someone print it for you on their FDM printer. I think the infill was roughly 30-40%, so it's very rigid. I have had no issues with it bowing. I can't tell any change in the sides here from the tension of the FEP. It's just PLA filament, so it's extremely cheap. The whole vat probably cost me $10 or less worth of PLA to print. I printed it on a TiVo Tornado, which has a 300mm by 300mm bed. And actually bought that and sold my smaller FDM printer so I could print the vat, because I knew I had to get something larger in order to make the vat out of one piece. But yeah, that's pretty much it. A two-piece vat, cheap, made out of PLA, works beautifully. And you just put these little nuts on here and spin them down in case this one wants to start. You do have to thread these nuts, by the way, so you print them and then you take a M5 tap and tap the threads into them so they spin on easily. But yeah, that's pretty much it for the vat. Okay, so the tools you're going to need to build the machine are a set of these boneless, I don't know how I say it, Allen screwdrivers. These are a must. If you're using an Allen wrench, there's some places that you probably will not be able to run the Allen screws. And even if you did, it would take you forever, so get a set of these. I have a set of Husky mini pliers. I am not a representative for any of these companies, but I really like Husky tools, especially these needle nose pliers. They come down to a very small tip, and a lot of places where your fingers can't grab or reach, these things will work. So they're awesome. I use these for cutting wire and other stuff, tape, whatnot. And you need a set of small screwdrivers, such as this. These are Huskies again. Very useful for screws and tight spots and stuff like that. They're very nice. So you're going to need a 5mm tap, because when you assemble the frame, you got to tap threads into the frame. You're going to need a chop saw for cutting the V-slot, unless you have a service cut it for you. So if you want to cut the frame yourself, you're going to need a chop saw with a carbide tip blade on it, so it'll cut clean through the aluminum. And make sure it's absolutely perfectly square, because if it's not, your frame will not line up. You're going to need just a regular household drill. You're going to need a 40-watt soldering iron to do the soldering on the wiring. You're going to need basic soldering skills. I'm not going to explain to you guys how to do soldering, how to wire up. You got to know that stuff already, so look that up if you don't know how to do that. You're going to need a Dremel or a CNC/laser cutter. So the acrylic case, these cutouts here for the fan, for the plugs, power switches and stuff like that. That's all. I did all that by hand because I do not have a CNC machine or a laser cutter, and I didn't want to pay $100 for someone, $200 for someone to cut these out. The case was expensive enough as it was, so I just basically hand marked them and cut them out with a Dremel. So either use a Dremel and do it by hand, and a little set of files. You'll need a small set of files as well to clean up the edges, or you'll need a CNC laser cutter if you have access to one of those. And you're going to also need something like that for the print platform. So when you're cutting out that mesh I was showing you guys on the print platform, you need the Dremel to make those holes beveled so the screws will sit down flush. If you don't have a Dremel, good luck. That perforated steel is very difficult to work with, so you're going to need a Dremel to countersink, as it were. But you have to manually basically countersink the holes because of the perforation. So that's pretty much it as far as the tools go. And just to show you guys what the machine is capable of as far as detail, and that it does work. This was printed. This is a elf bust, they call it. It's off Thingiverse. But it's a very detailed model to test your printer with. All I gotta say is, if your printer is not working perfectly, this thing will never survive. It's extremely difficult for the printer to print because of the geometry. It doesn't look that difficult, but by the time you get supports for the ears, especially these arms that basically start cut off, but they're above the torso, so they require supports. This is very difficult to print, so if you want to do a torture test in your printer, print this. You do want to hollow it out with mesh mixer. Make sure you don't waste a bunch of resin. Hollow it out and put some drain holes in it. But it does have flaws. You can see one of the ears here is broken off. This ear got broken off. All the arrows survive back here in the quiver. They look great. It's a little bit blurry because at the time I had a filter on the screen that was diffusing the light too much. So some of these features are a little bit oversized, but not enough that you can really tell. This little braid of hair here that comes down the side of her face also broke as well. But this was before the machine was completely finished, so I didn't have the cure times I have now. When it's finished completely, I would think I was running around 15 seconds for the layers, which is much longer. That takes way longer to print than 8 and 6 seconds. And this was not an ideal resin for fine work because it was the firm resin, which I found out later isn't that strong when it's semi-cured. So in other words, when it's still on the print platform in the resin, it's not fully cured. It doesn't fully cure until you rinse it off and put it in a curing box. So when it's at that partially cured stage, the resin itself is pretty fragile, especially when it comes to small features like this. So I did order some hard resin, which is better for detailed parts. The photocentric hard. This was the photocentric firm. And this was printed, I'm going to move this back a little bit here so it's out of the way. This was printed on the red hard resin. So hopefully it's in focus there. It's extremely small. To give you an idea, this thing barely fits the pinky. It will not fit the ring finger here, or barely. It doesn't really fit all the way on, so it's very tiny. This flower on the top survived beautifully. I'm going to move a little bit just in case it's out of focus. The entire flower is made up of a honeycomb mesh pattern, so it's very delicate, the leaves. But everything survived beautifully. The band, obviously, is another web pattern. And I thought for sure this would break. I just put it on the platform as a joke to see if it would survive, but I didn't expect it to survive, so. Very finely detailed, and it survived beautifully. This is the hard resin. So, like I said, it can handle smaller details without breaking during the print because it's much stronger at that intermediate stage where it's partially cured. The only reason the band broke down here in the bottom, you can see down here in the very bottom it's broken, is because when I had to cut this off the platform, I might have set the bottom layers here a little too high, so it was stuck a little too well, and in the process of getting it loose with a putty knife, I accidentally broke it because it was still, in that partially cured stage. So, but if it hadn't been for that, if I had set these lower layers to cure a little bit slower or a little bit less time, it would have come off and I wouldn't have broken it. So, and these were 8-second layers, by the way. So this is photocentric hard red resin running at 8-second layers. So for something this fragile to survive with an 8-second cure is very good. So if I was to print, I haven't gotten around to it yet, but if I was to reprint the elf in the hard resin with 8 or 9-second layers, it would probably come out flawless. So anyway, that's a sample of the detail that the printer is actually capable of.